We are told the ancient world relied on limited medicine. Herbal preparations, rudimentary surgery, animal-derived compounds. The official account describes a civilization operating without systematic pharmacological knowledge, working with what grew nearby, guided by trial and error over generations. That account has a problem. For at least 6 centuries, across the ancient Mediterranean world, a single plant was documented as the dominant treatment for an extraordinary range of conditions: fever, cough, indigestion, menstrual irregularity, pain, skin lesions, infection, and, most specifically, as a reliable method of preventing or ending pregnancy. It was prescribed by physicians, catalogued by botanists, traded as a luxury commodity worth its weight in silver, depicted on coins, and referenced in literature as though its effectiveness was not in question. Then it disappeared. Completely. Not gradually. The references stop. The trade routes that carried it go silent. The plant itself, by most accounts, no longer exists. Its name was Silphium. The question is not whether it existed. The documentation is too extensive, too consistent, and too geographically distributed for that to be seriously doubted. The question is what it actually was, why it cannot be identified today, and why the explanation for its disappearance is considerably less certain than the historical record suggests. The ancient city of Cirene, located in what is now northeastern Libya, built its entire economic identity around this plant. Cirene was a Greek colonial settlement, founded around 630 BCE, and within 2 centuries it had become one of the wealthiest cities in the ancient Mediterranean. Its coins, the physical currency of its economy, did not depict a ruler, a god, or a military symbol. They depicted Silphium. Specifically, they depicted the seed of the plant, in a shape that has since become one of the most recognized symbols in the modern world, a symmetrical, heart-shaped outline. That detail alone is worth pausing on. A city prosperous enough to mint its own coinage chose a plant as its defining symbol. Not the weapon. Not the deity. A medicinal crop. The economic records that survive, fragmentary as they are, describe Silphium as one of the most valuable traded commodities in the ancient world. Roman accounts place its price at roughly equivalent weight to silver. One account, attributed to Julius Caesar's administrative records, notes that a specific quantity of Silphium was kept in the Roman treasury alongside gold and silver reserves. That is not how a culture treats an ordinary plant. That is how a culture treats a strategic resource. And yet it reportedly grew only in one place, a narrow coastal strip of land around Cirene, stretching perhaps a few hundred kilometers along the North African coast. It reportedly could not be cultivated. Every attempt to transplant it, according to the ancient writers, failed. It grew in the wild, on a specific elevation of hillside, in a specific climatic band, and nowhere else. The entire global supply of this substance came from one geographically constrained region. This raises a technical problem immediately. A commodity that cannot be cultivated, grows only in one location, is in such high demand that it commands silver-equivalent prices. And is being consumed by an empire, that commodity has a very short operational lifespan. The mathematics of extraction without replenishment produces a predictable outcome. What is less predictable is the silence that follows. The ancient medical literature on Silphium is not vague. That is important to establish. These are not folk references or poetic metaphors. The writers who documented Silphium were operating within what they understood as a systematic medical tradition. Dioscorides, writing in the 1st century CE, described specific preparations, dosages, and applications. Theophrastus, writing 3 centuries earlier, described the plant's morphology in botanical detail, its root structure, its juice, its seasonal behavior. Pliny the Elder, compiling natural history in the same century as Dioscorides, described what appears to be its final decades of existence with the specificity of someone recording a current event. What the literature describes is a plant whose juice, called laser, was the active compound. This juice was extracted from the root and stalk, and was apparently potent enough that very small quantities were effective for medical purposes. The range of applications documented spans wound treatment, throat conditions, joint pain, fiebre, digestive conditions, and, listed repeatedly and explicitly, as an emmenagogue and abortifacient. An emmenagogue is a substance that stimulates or regulates menstrual flow. An abortifacient is a substance that terminates pregnancy. These are not minor footnotes in the record. These are consistent, repeated applications documented across multiple independent sources spanning centuries. The ancient world was evidently describing something that reliably worked in these specific applications. They were not describing a legend. They were writing dosage instructions. This is where the gap between the historical record and current understanding becomes most difficult to explain. Modern pharmaceutical research into plant-based compounds with reliable contraceptive or abortifacient properties is extensive. The search for effective, plant-derived compounds of this type has been ongoing. And yet Silphium, a plant documented by multiple ancient medical authors as reliably effective for exactly these purposes, cannot be chemically analyzed. Because the plant cannot be definitively identified. The official explanation is that Silphium was driven to extinction, most likely sometime in the 1st century CE. The evidence offered for this is a passage in Pliny the Elder suggesting that the last known stock was sent to the Emperor Nero as a curiosity. After Pliny, the specific plant disappears from the literature. But this explanation accounts for the extinction. It does not account for the composition. If Silphium was pharmacologically effective, and the consistency of the ancient documentation makes that a reasonable hypothesis, then it contains specific chemical compounds that produce those effects. Those compounds do not require us to have the plant to reason about their existence. And the question of what class of compounds would produce the documented effects across fever, inflammation, infection, and reproductive function simultaneously is not a trivial botanical question. Several researchers have proposed candidate plants, species in the genus Ferula, which is in the same family as the documented botanical relatives of Silphium. Some Ferula species do contain compounds with demonstrated biological activity. Ferula asafoetida, a close relative, has been used medicinally across multiple cultures. Studies on certain Ferula species have identified compounds with demonstrated effects on reproductive hormones in animal models. This does not confirm that Silphium was one of these species. But it does suggest that the ancient documentation is not pharmacologically implausible. The candidate remains unconfirmed. The disappearance itself deserves more scrutiny than it typically receives. The standard account describes overgrazing and overharvesting. Cirene exported Silphium to Rome and to the broader Mediterranean trade network in such quantities that the wild population, unable to be cultivated, was simply exhausted. This is ecologically coherent as a mechanism. Species that cannot be cultivated and face intense commercial extraction are vulnerable to exactly this kind of collapse. But the detail in this account does not resolve cleanly. If Silphium was worth its weight in silver, the people of Cirene would have had every rational incentive to manage its harvest. The city's wealth depended on it. The Romans, who were not historically reluctant to use administrative control over strategic resources, were receiving it in volume. There is no documentation of conservation measures, harvest limits, or attempts to regulate extraction. There is also no documentation of failed attempts at conservation. There is simply documentation of the plant's existence, and then its absence. More specifically, there is no documentation of the transition period. No account describes a decade of declining yields. No writer notes a shortage, a price increase, a change in trade patterns. Pliny describes the last known stock as though recording a curiosity, not a crisis. The disappearance appears abrupt in the written record, not gradual. This is not proof of anything other than incomplete documentation. But incomplete documentation is precisely the pattern that requires examination. When a commodity with this level of economic and medical importance disappears, the absence of a recorded transition is itself a data point. There is another possibility that the standard account does not seriously engage with. Silphium may have been misidentified in the ancient literature itself, and may still exist in some form under a different name. Several researchers have argued that what the ancients called Silphium may correspond to a plant that survives today. Perhaps as a species that was botanically reclassified or that grows in a region that was not systematically surveyed in the period when the identification question was being actively investigated. In 2017, a Turkish researcher proposed that a plant known as curarlo, a species of ferula documented in the same geographic range as ancient Cyrene's hinterland, might be the plant historically identified as Silphium. The proposal was based on morphological similarities, geographic distribution, and the correspondence of traditional local uses with ancient medical descriptions. The proposal has not been confirmed, but it has also not been definitively refuted. The plant in question has not been subjected to the full chemical analysis that would be required to test the hypothesis. The point is not that this specific candidate is correct. The point is that the identification question remains genuinely open, and the institutional appetite for resolving it appears limited. There is a broader pattern into which Silphium fits, and it is worth examining that pattern directly. The ancient world documented a number of substances and techniques that the modern historical account treats as either exaggerated or simply lost. Some of these fall into the category of construction, building techniques that appear in the physical record without a satisfying explanation for how they were achieved. Others fall into the category of chemistry, formulations, preparations, and compounds described with specificity in the ancient literature that have not been replicated or identified. Greek fire is one such example, a naval incendiary weapon documented extensively in Byzantine military history. Described in enough technical detail to establish that it was a real substance with real properties, and yet its composition remains unresolved after centuries of scholarly investigation. Silphium occupies a different category. It is not a manufactured compound. It is a biological organism. It should, in principle, be identifiable. If it still exists, or if it existed in a related form, its chemistry is preserved in whatever living specimens correspond to it. What is notable is not that Silphium is mysterious. What is notable is that the mystery appears to attract less active investigation than its historical and pharmacological significance would suggest it warrants. A plant described as medicinally effective for a range of serious conditions, documented by multiple independent ancient sources, with a plausible botanical family to which it may belong, would ordinarily be a significant research target. The pharmaceutical relevance of identifying effective plant-derived compounds for the application Silphium was documented to address is not hypothetical. It is a live area of medical research. And yet the identification question has not been systematically resolved. The heart-shaped seed depicted on Cyrene's coins is worth returning to. That symbol, the outline of the Silphium seed as depicted in ancient numismatic art, is visually identical to the modern heart symbol used across global culture today to represent love, romantic attachment, and human emotion. The correspondence is precise enough that several researchers have proposed it is not a coincidence, at the modern heart symbol, rather than deriving from the anatomical shape of the human heart, which it does not accurately represent, may be a surviving trace of the Silphium seed symbol, preserved through centuries of cultural transmission without the original referent. The anatomical argument is straightforward. The human heart is not shaped like the symbol that represents it. It does not have two symmetrical lobes curving to a point. The ventricles do not produce that profile from any standard viewing angle. Multiple explanations have been proposed for how the anatomical heart came to be depicted in the stylized form that now represents it: artistic convention, medieval anatomical illustration, cultural inheritance from earlier traditions. None of them is fully satisfying. The Silphium hypothesis suggests something different, that the heart symbol was originally an image of a seed, specifically the seed of a plant associated in the ancient world with love, sexuality, and reproductive function, all of which Silphium was documented to be connected with. And that as the plant disappeared, the symbol survived in a context that was adjacent to its original meaning, but that severed the visual sign from its original referent. These cannot be verified. The chain of transmission is too long and too poorly documented to establish definitively. But the morphological correspondence between the numismatic depictions of the Silphium seed and the modern heart symbol is real and visible. And the disconnection between the modern heart symbol and the organ it supposedly represents is also real. What it suggests, if the hypothesis has any merit, is that a symbol used by millions of people daily may be the last surviving trace of a plant that no longer exists, a trace that has outlasted the object it originally depicted by more than 2,000 years. There is a specific category of historical loss that the disappearance of Silphium may represent, and it is worth describing clearly. It is not the loss of a tool or a building technique. It is not the loss of architectural knowledge or metallurgical skill. It is the potential loss of a pharmacological system, a body of practical knowledge about the chemical properties of a specific organism, developed through centuries of empirical application. Documented in texts that survived, and yet ultimately disconnected from the substance those texts describe. The ancient medical tradition was not primarily theoretical. It was observational and empirical. When Dioscorides described how to prepare a compound and in what quantity to administer it, he was recording accumulated clinical experience, not speculation. When multiple writers across multiple centuries described the same plant producing the same effects, they were documenting something they had observed or that had been reliably transmitted through their medical tradition. The implication is that effective pharmacological knowledge was developed, documented, and then severed from its material basis by the disappearance of the source organism. The knowledge survived in the texts. The substance did not survive in the world. And without the substance, the knowledge became unverifiable, neither confirmable nor refutable by any empirical test. This is a specific and unusual kind of loss. It is not ignorance. It is documented knowledge that became inaccessible without anyone deliberately suppressing it. The texts are in libraries. The coins are in museums. The botanical descriptions are in translation. Everything is preserved except the plant. Or possibly, everything is preserved except the identification. The question of why Silphium specifically grew only around Cirene was not, in the ancient world, explained in chemical or ecological terms. The ancients described it as a fact of nature, it grew there, it could not be moved, and that was the condition of its existence. Modern ecologists would frame this differently, as a species with a very narrow ecological niche, dependent on specific soil composition, elevation, rainfall patterns, and perhaps specific pollinators or microbial associations that could not be replicated elsewhere. If that framing is correct, then the North African coast in the 1st or 2nd century CE underwent some change, climatic, agricultural, or demographic, that disrupted those specific conditions. What remains unexplained is why that disruption was total and irreversible rather than partial and documented. Climatic shifts in North Africa during the late Roman period are documented. The region that is now Libya and Tunisia experienced changes in land use, vegetation cover, and water availability over the centuries of Roman administration. These changes were gradual. But species loss is sometimes not gradual. A species with narrow niches and no capacity for cultivation are vulnerable to threshold effects. The population can sustain moderate pressure until it cannot, and then the collapse is rapid. This is ecologically coherent. It is also convenient as an explanation in the sense that it is unfalsifiable. A species that no longer exists and was never preserved cannot be chemically analyzed to determine whether it was genuinely as effective as the ancient record suggests. The extinction, if that is what occurred, closes the question before it can be fully examined. What we are left with is the documentation, the coinage, the museum cases, and the ongoing uncertainty about whether a plant worth its weight in silver, capable of functions that remain pharmacologically relevant, and depicted on currency for centuries, was truly driven from the earth without a trace. Or whether the identification has simply not yet been made with sufficient rigor. The official account of Silphium is broadly accepted, minimally contested, and rarely foregrounded as a significant unresolved problem. It appears in histories of ancient medicine as an interesting detail. It appears in numismatic scholarship in the context of the heart symbol hypothesis. It appears occasionally in popular science articles as an example of a lost species. It does not appear as an active pharmaceutical research target, despite the documented medical applications. This is worth noting not as an accusation but as an observation. Research priorities reflect institutional assumptions about what is worth investigating. If the assumption is that ancient medical documentation, however consistent, reflects the placebo effect or cultural belief rather than genuine pharmacological efficacy, then the identification of Silphium produces no expected pharmaceutical insight. The research investment does not appear to be made. If the assumption is reversed, if the consistency and specificity of the ancient documentation is taken as prima facie evidence of genuine efficacy, as it arguably should be, then the identification question becomes considerably more urgent. Not historically. Medici. The ancient writers were not describing a ritual plant. They were not describing a symbolic or ceremonial substance. They were describing a medical tool with specific applications and observable results, administered in measurable doses, recorded by physicians in a systematic tradition. The question of whether the tradition was correct about the plant's effects is not answerable without the plant. But the question of whether the plant still exists, or has been misidentified, or corresponds to a surviving species in the same genus that has not been chemically characterized, those questions are answerable, in principle, with the tools of modern botany and pharmacology. They have not been answered. There is a category of historical problem in which the evidence for something is extensive, consistent, and well documented, and yet the thing itself is absent. This is different from a mystery in the ordinary sense. It is not a question of whether something happened. It is a question of what happened to the knowledge that remains. The coins exist. The medical texts exist. The botanical descriptions exist. The trade records exist. The symbol that may derive from the seed exists and circulates in a billion instances daily. What does not exist, or what cannot be confirmed to exist, is the plant itself. That inversión, preserved record, absent subject, is the specific character of the Silphium problem. And it is worth asking, without arriving at a conclusion, what other pharmaceutical knowledge may be distributed across ancient texts in a similar condition, documented, preserved, translated, and ultimately inaccessible because the organism or compound it describes can no longer be placed in a laboratory. The ancient world did not lack observation. It lacked the institutional infrastructure to preserve the material basis of what it had observed. The texts survive. The libraries, partially, survive. The organisms, in some cases, did not. Or the organisms survived, and the connection between what we call them today and what the ancient writers called them was simply never made. The record is there. The gap is in what the record points to. The plant said to heal everything still has a description. It has a price. It has a shape that may still be traced on envelopes and valentines without anyone knowing what they are drawing. What it does not have, 2,000 years after Pliny recorded the last stock, is a confirmed identity. The documentation survived. The subject did not, or has not yet been found.